That's all 2D imagery that's wrapped around the globe. When you get closer to the ground, we have 3D data that we collect from planes.
Yes, you heard right, planes. I'd always assumed that every overhead photo of the Earth I'd ever seen was taken by satellite. But I learned creating 3D imagery requires special conditions. So Google flies planes, or as I now like to think of them, street view cars with wings.
What are some of the challenges that you guys had?
The biggest challenge in doing something like this is weather. Our preference is always to have clear skies.
It took us a really long time to get London because we had to fly over London a lot before we got a fully cloud-free image of London.
Come on in.
Nice.
Kevin told us that a typical flight to take photos is around 5 hours, except the planes aren't going across the country, they're making little zigzags over the same area.
So it's north and turn south. It's sort of like mowing the lawn.
This pattern helps the photos overlap, and multiple cameras help capture a place from different angles.
In planes, we have 5 different cameras, one looking down and forward, back, left, and right.
In my mind, I'm picturing photograph, 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 photograph.
Yep.
And then something puts them all together. Something called an algorithm.
Photogrammetry, yeah.
Which is just a fancy word for taking all of this imagery that we collect from the plane and constructing a 3D model.
The first step to creating a place in 3D is a little bit of photo editing.
So all the imagery is sort of prepped. That would be removing clouds, removing haze, color correcting. You'll actually see that a lot of the cities don't even have cars in them. We actually take the time to extract those.
Then the 3D science begins.
The big breakthrough that's happened in the last few years has been the introduction of computer vision. The computer looks for features within the overlapping images that are the same. We use a special GPS antenna that allows us to know where that camera was. So we know roughly where things were taken and at what angle.
And this allows them to create a depth map.
And that's just our understanding of how far the things are from the camera. And we take all of these various depth maps from the different cameras, stitch those together in what's called a mesh, which is basically a big 3D reconstruction of the place, and we texture it. And texture it is applying the photography that we took to the sides of these 3D buildings. It's almost like taking pieces of paper and cutting them up. You can actually extract the edges of something and then stitch those together and then understand what that shape might be. And organic shapes are what's hard to render. It gets even more complicated when you're talking about trees, because trees have branches and leaves, and often you might see them as a lollipop because that's as good as we can get. But we're getting better at modeling those organic shapes. We did a collective Yosemite National Park, and we were able to actually capture that in really high fidelities with all the different bends that a rock face might have.
Do you know how many different images make up what I see as Google Earth?
Yeah, it's probably on the orders of tens of millions. One interesting stat is to look at what we call Pretty Earth, and this is the global view. So we have a full seamless image, and that comes from about 700,000 scenes from Landsat. And what we're doing is we're finding the best pixel from each. So if you look at Google Earth, it's springtime everywhere.
To be precise, an 800 billion pixel spring globe, which is so big, if you wanted to print that out on your home printer, you would need to find a piece of paper the size of a city block.
If you took a single computer, it would take 60 years to process that.
And you can just keep multiplying this times all the different levels of zoom that exist in Google Earth.